Welcome to What's New in Data. I'm your host, John Coute. Today we're joined by Clare Liguori, Senior Principal Engineer at AWS. Clare recently announced Strands Agents, a lightweight open source SDK that's already powering agent workloads at Amazon Q Developer, Glue, and much more. And now that it's open source, the whole community gets to benefit from the simple abstractions that it gives us for building agentic applications. We're going to dive into the core principles behind Strands Agents and also some practical advice for software engineers to break into AI engineering and how it's a little bit different from what they're used to. But more than that, Clare shows us what it means to think big about AI and how powerful it can be when you just start hacking on real problems. Let's dive right in. Hey everybody, thank you for tuning in to this episode of What's New in Data. Super excited to be chatting here with Clare Liguori, Senior Principal Engineer at AWS, working on Strands, among many other exciting projects. Clare, how are you doing today?
Good. Thanks for having me on.
Absolutely. Clare, tell the listeners about yourself and your journey into this space.
Yeah, I've been at AWS for almost 11 years now. And throughout that whole journey, I've really been focused on developers and developer experience. And let's see, over 2 years ago, generative AI as a real application for users was exploding. There's ChatGPT going on. Lots of new models were coming out. Lots of new projects were coming out. And I started to think, as well as others at AWS, about how generative AI could change how we develop code, how we create applications as developers. And that really led me to start thinking about agentic AI as well, when you can let the AI write an entire application for you and interact with the world for you, to pull in information and manage your AWS resources and things like that. So over the last couple years, I've been so excited to see how powerful models have become to enable building AI agents.
Absolutely. AI agents are already proving their value both for the indie developer and the enterprise. And I think one of the cool things about AWS is it has that range of being valuable to all those types of developers. Would love to hear about your launch with Strands and what the product is.
Strands Agents is a open source library for developing AI agents. One of the key design choices that we made with Strands is that it's what we call a model-driven approach. When I started building AI agents back in early 2023 with Anthropic Claude V1, I think 1.3, I was looking at some of the code today. We were just starting to build agents in the industry. I think the original React paper that showed that LLMs could interact with their environment through tools had just come out, but it was super hard at that time. I remember at the time using Claude, you had to put all of these instructions and examples in XML tags and things like that. And you couldn't really get it to do much that was complex. So one of the first agents that I tried to write was troubleshooting problems with your AWS resource configuration. Things like, you get this very opaque error message that something's broken with your application, but you don't know what. And so I was trying to figure out, well, could agents just kind of explore my AWS account and figure it out for me? And at the time, they just couldn't deal with that much complexity. And so you had to kind of fall back to prompt chaining, agent chaining, very explicit agent workflows for very explicit, specific use cases that those agents would be able to complete tasks for. But over time, now that we have this sort of latest crop of large language models, they're so much more capable of driving agents themselves. And that's really where we came to this model-driven approach, because we were seeing that actually we didn't need a lot of complexity in some of the internal agents we were building at AWS with all of this chaining and workflows and things. that you could really throw the tools directly at the model, and the model can figure out which tools to run, and is actually a lot better at complex use cases now. And so you don't necessarily have to create a bunch of individual agents that are sort of domain experts. You can actually have one very generic agent with a set of tools. So that was really the beginning of Strands Agents, was us internally within one of the products I work on, Q Developer, realizing that there was a simpler way, and it was actually even more higher quality, because this is now how these models are being trained. They're being trained to use tools. So we started to re-implement, throw away some of our agents internally and rebuild on this model-driven approach. And we were seeing it was a better user experience, it was more accurate, and it was actually faster for us, right? It's obviously faster to develop something where you write a prompt and you give it some tools, and off you go. So that was, we started developing it internally for us at AWS, and then we started seeing such great impact internally for us that we wanted to release it for the community. And so this model-driven approach is really at the core of it, where it's really focused on, let's leverage the power of how powerful these models have become, especially with tool use, and get rid of a lot of the complexity that came from using earlier models like Claude V1.
Yeah, and that's a great call out that these LLMs are now being trained on using tools. We'll get into this, but some of the protocols that are coming out, like MCP and A2A, lots of acronyms, these are all sort of materializing, and they're productive. There's certainly a lot of interesting directions this can go in, but it all starts with the model, like you said, and having the models, the prompts, the evals, the tools, like as your kind of core building blocks. And then from anything there, you could kind of from those abstractions, you can build applications on top. Like, what are the other core architectural principles behind Strands, and how do they reflect a shift in how these agent systems are being built?
Well, a couple are, one, it's not tied to any particular model, just that your model have reasoning capabilities and tool use capabilities. And what we're seeing is that lots of models are now being trained that way. And lots of models either have sort of a messages API or a tools API in the case of Anthropic APIs. And so we were really cognizant early on of what are the interfaces that we're providing for you to be able to plug in your favorite model. That could be something that's running locally on your laptop with Olama. It could be something that's running on AWS with Bedrock. But we also partnered with Anthropic to provide Anthropic API support, Meta for their new Llama API. And we're working with a lot of other partners to provide additional APIs. So we wanted it to be something very flexible, and that's in that case of, regardless of what provider you're using, we're finding that there's a lot more consistency in interfaces to models these days. And then we're also seeing more consistency, of course, in interfaces to tools, like you said with MCP. That's been amazing for having a more standard interface across whatever agent framework you might be happening to use, but then also for the tool author to be able to provide MCP and servers for anybody to use regardless of their agent framework. And so it's been amazing to see the growth in the community of those MCP servers. I mean, there's thousands now out on GitHub and on PyPy and NPM. And you can bring any of those to Strands, right? So we're trying to support standard interfaces as much as we can. It supports open telemetry, so you can bring in whatever telemetry provider you prefer. And then you can run it anywhere. It doesn't need to be, it can run on AWS, or it can run on your laptop or anywhere else you need to run it. So we wanted to provide something that wasn't tied necessarily to any individual provider, but really instead showcase this model-driven approach that's been so powerful for us.
And that's a very astute point that, you have the model and you can have multiple models and you can have multiple runtimes, and,
Mhm.
having the power to sort of develop locally and then scale in the cloud, and not be restricted, based on, your code shouldn't be tied to, one specific environment. So it's taking a lot, like when I looked at it, I mean, it seems like it's taking a lot of just software engineering, both scalable principles and practical, like making it easy to develop with. And I like the other part, like you mentioned, it's model driven, but it can work with multiple models, which is
Mhm.
becoming pretty standard for AI application development, even if you're doing things like LLM as a judge, or model cascading, and you want to test, cheaper models through some workflows, and then, potentially have to fall back to more expensive ones,
Mhm.
if the cheaper fast model is not working as well. So it's super flexible, and I think it's a really nice reflection of where AI applications are standardizing in their approaches. Diving in deeper into MCP and A2A and these types
Mhm.
of things, I would love just your take on it. Like, where do these like emerging protocols, uh, like I mentioned, MCP and A2A, sort of redefine the communication between intelligence systems?
One of the specific use cases that we've seen for multi-agent, because I think there's what we've seen is that agent to agent communication is not always need to be something special. So we've had a lot of success with internally with the agent as tool model, where the agent is a bit more of a sort of a request response, where the sub agent, you're calling it as a normal tool. You could put it behind MCP, you give it a prompt, it comes back with a response. We have multiple systems internally that run that way. And some of that is because there are agents that have specialized knowledge, or which really ends up being specialized access to data, right? But often what we see is it's also a way organizationally to to split up a very complex system into multiple teams. Right. So at Amazon, we're kind of famous for the two pizza team, and letting teams own their whole system. And so, in some ways, multi-agent is sometimes more of an organizational solution, where you have five different teams that want to own some experience or domain expertise in an overall agent system. But we do see some more complex use cases for agent to agent communication. So, one challenge that we've had with MCP is with MCP being able to model many, many tools. So, for example, we have an agent internally that models more than 6,000 tools. So those map to a huge number of AWS APIs, and that's you can't put that in your prompt context, right? If you have an MCP server that exposes 6,000 tools, you'll probably blow out your context window, and if not, your requests are going to be very slow and very inaccurate in terms of what tool it chooses. And so we've done a lot of work around agents where inside of this sort of sub agent, it does a lot of work around selecting the particular tools that you should expose to the LLM based on the customer's input. So, if they asked about S3, it's probably going to be an S3 API. If they asked about EC2, it's going to be an EC2 API. And sometimes it's a little bit more um, um, ambiguous, like they might ask about a function and not say Lambda. So being able to figure out, what are those maybe top five most relevant tools for the LLM is something that agent to agent communication has been really helpful for us. And being able to maintain state across a session in that sub agent. In the agent as tool use case, often you don't necessarily save state in that sub agent. It's that request response and I'm done. But we have some of those use cases, especially around that selection of within 6,000 tools for the session. becomes very important. We're doing a lot of work with, we're doing some work with A2A. We have an example of using Strands with A2A. And that enables you to do, to kind of hook into that entire ecosystem of having agents talk with agents that could be implemented in any agent framework, right? You might have some LangChain, you might have some Crew, you might have some Strands, and they can all communicate together. But we're also doing a lot of work in the MCP community upstream to try to evolve that to be able to support agents communicating over the MCP protocol, which is super interesting. So one example is a few weeks ago now, I think we got merged a new feature in the MCP spec called elicitation, where the MCP server can respond back with an elicitation along the lines of, I need this information from the end user. And the core agent, goes off and returns control back to the human user. And that's going to be super important, of course, for agent-to-agent communication. So I think it's very interesting to see, both how these both evolve, right? But also how we start to think about the lines blurring between communicating with agents and communicating with tools if they're in the same interface.
So at a high level, and tell me if I'm oversimplifying, but would you categorize MCP as the best way to for agents to communicate with tools, and then A2A is the best way to have like these multi-agent communication?
Today, yeah, that's the pattern that I tend to see, is where, it's really simple to wrap MCP, the interface around an agent. It's an API that you can stand up. So we've had customers have success with, for example, putting an agent inside of a Lambda function and then just putting making that an API that is MCP compliant. Some of the work that's been done upstream in MCP, I think, has more enabled this. So in the original spec, it was just mostly local MCP servers, which was great for IDEs and chat clients. And if you look at those thousands of MCP servers out there, they're not actually servers. They're really just local process with, standard IO streams to your chat client locally. But where I see the industry going is really embracing what we call the remote MCP server, right? The MCP server that's just behind an API. And that's really just become possible, I think, in the last couple of months, even as the upstream community has been adding new ways of building scalable MCP servers that are remote with something called the streamable HTTP transport, which
Yeah.
basically just means putting it behind more familiar HTTP APIs.
Yeah, and that's definitely a big boost for performance and just some other things like that you would expect an API to deliver. So that's a really exciting
Mhm.
drop for sure. And like you mentioned, it just became available in the last few months. Every time I just listening to these episodes back in January, like there's been so much innovation even since then. I think like the rate of development in AI obviously correlated with the AI code gen tools, but
Yeah,
and then of course the excitement and the value it's bringing. And
yeah.
and when you look at the frameworks that now companies like AWS are delivering,
Mhm.
like you said, you've been working on this since 2023, but just on the Q developer side, and the amount of applications you've seen built then versus now, obviously a huge change in the amount, but also the requirements around them, being able to handle the scale of these data processing engines and databases, and making it streamlined for enterprise application development, and then of course like even the SMB and mid-market ones as well that have
Mhm.
large data volumes. So that's been just really fun to see, and I felt like it was a great turning point in the industry when you saw uh, Strands agents come out, because it's just sort of this kind of light layer of abstractions to build these applications. And it's really grounded in this idea, like you said, that we start with the models, right?
Mhm, mhm.
Which is a powerful way to look at it.
Definitely. And I think one of the interesting things that I'd seen over the last, I would say 6 months maybe, is how differently we think about this model driven approach in terms of even just information, right? When we all kind of started out building agents, it was all about RAG. Right before you called to the model, you always supplemented your context with pulling from some vector DB, right? And one of the things I'm starting to see now is what internally one of my colleagues calls retrieval as a tool, as opposed to retrieval augmented generation. I don't love the acronym RAT, but but there it is. Um, so we're seeing a lot more of don't actively give information to the model that might be too much information, or even information that it doesn't need. Like if it has enough information in its training data, you might actually make things worse by proactively giving it information. Instead, create a tool that can retrieve information for it. So as opposed to proactively having kind of a prompt pipeline where you always augment that prompt, instead provide that vector DB as a tool where it can retrieve documentation. And I think one of the places where we're seeing this that's interesting is in actually a lot of the development tools with MCP. So we're seeing a lot more of what I call documentation MCP servers, where in the agent space, especially, I was looking at the training dates recently of the latest Claude models, and since Claude 3.7 came out, there's been like 10 new agent frameworks. And then even since Sonnet 4 came out, I think I read that their training data ended in March of this year. Strands came out in May. And so it doesn't even know about Strands yet. And so we're starting to see a lot of these projects provide LLMs.txt, so you can retrieve those through an MCP server. And again, the MCP server is a tool, so it's letting the LLM decide, when do I actually need this information for my task, versus kind of proactively throwing a bunch of information at it. So that's been a big change in sort of those data access patterns that we've seen from moving from that prompt pipeline where you would try to get it every time, and then letting the model decide when it needs that information.
Absolutely. And timely, because just at least from the time we're recording this episode, last week in the Strands GitHub repo, and that's one of the other great things about Strands. There's so many great, actionable, easy to run examples on the GitHub. I'll have that down in the link to that in the show notes. But there was just recently one that came out with Amazon Aurora DSQL
Mhm.
running through Strands agents. And just like you mentioned, it's retrieving data with these tool calls, right? So you look at the architecture diagram, and it's reading read-only query, it's doing transactions, there's get schema, and different just high-level tool call APIs that interact with the database. And
Mhm.
when Mark Brooker, he was on What's New in Data last season, and we were talking about how agents and serverless databases actually are very complementary technologies. So it's very cool to see sort of the materialization here, and
Mhm.
like you said, it's super powerful to, rather than having RAG and trying to like populate your prompts with context kind of manually, or overloading it.
Yeah.
The agent can kind of decide when it wants to make a tool call to retrieve very specific data with specific parameters, and it makes the application more deterministic.
And we've also seen that it also makes it much more generic, right? You don't have to have a very specific prompt pipeline where you determine the query to the database ahead of time and then add the data to the prompt. You're able to apply these agents to much more generic problems than you could before by effectively teaching the model how to query, and then giving it some boundaries, right? Giving it some guidelines. But generally, it's much more flexible for a lot of different tasks that you could throw at it.
Yeah, absolutely. And it gives it good guardrails for things like data access.
Hmm.
Even in that example, there's, it specifies, read-only queries and
Hmm.
retrieving schemas, but then it bubbles up into this powerful experience where, the agent can, get all the tables and do some operations, but a smart engineer who understands, how to set up database applications can still predefine those tool calls in a way that's safe and scalable, and you can even do your explain and analyze to, to make sure those are efficient queries, where you might have agents interacting with systems that with databases that are trafficked on other applications as well. So it's a very powerful concept, and it's so nice to
Yeah.
see in very succinct and well organized lines of code, how it can be implemented in that GitHub repo, along with a lot of other fun examples. And since we're on that topic, like, what's one of your favorite tutorials in that GitHub repo that you like to call out?
It's actually not in the GitHub repo. I put it in our blog post about the Strands launch. Um, when we decided to open source Strands. It had a different code name internally, right? And so we were trying to come up with, okay, what are we going to call this open source project? We need to come up with a name, and the lawyers have to sign off on it, and it can't be too similar to any other companies or whatever. And as it turns out, in the AI space, all words are taken. Everybody's got a blank AI, right? So we were having this trouble where we do a brainstorming session where we come up with, oh, this would be a really cool name, that would be a really cool name, and then we go and search on it online, and it would say, oh, of course it's taken already, right? Or we'd find one that didn't have a very clear company that was already using it, but someone had already registered the domain that we would want to use, or the GitHub org that we would want to use. And so I wrote with Strands a little bot that would help me to come up with names. So in the prompt, I would give it some guardrails around how we name things, and then some ideas of themes that I really liked. Like we had a DNA theme going. We had a sewing theme going as well for a while. We had like a car theme going for a while, where you would think about like a motor going around and around, or an axle going around and around. Anyway, so I gave it all this ideas, and then I gave it a few tools. I wrote a MCP server for my favorite thesaurus website, because I always felt that helps when I'm brainstorming. I wrote a domain name search, figure out whether it was registered or not. I discovered that through this, I didn't know this, who is no longer the hot thing for figuring out for domain name registration. It's now RDAP or RDAP. And as it turns out, the .dev TLD owned by Google doesn't support whois. It only supports RDAP. And so I was using this whois MCP server that I found, on GitHub, and it nothing.dev was coming back. And of course, we wanted to use them. We wanted to explore using .dev. This is a very developer focused project, right? And then I also had like the GitHub MCP server where it could look up possible org names. And that helped us just churn through ideas, which was really cool. And we were able to prove like, hey, this one doesn't work, because it's got these conflicts already. And that was just very exciting. One, it was super easy to write with Strands. It was, I don't know how many lines of code, but really small. And then also being able to take advantage of some of the MCP servers that are already out there. Like I was able to pull the GitHub one off the shelf, And then it was really easy to write up one where I was web scraping, my favorite thesaurus website to be unnamed, and then adding this domain name lookup one that I found. So it was just so easy to kind of pull these things together. And the most work that I was really doing was thinking about what are the real kind of business value, right? I was thinking about what are the themes that we want to explore, what are the names that we really like or don't like, as opposed to doing all this manual lookup. So it was really, really fun for me.
And that also speaks to the simplicity and how it was just able to aid your creative process
Mhm.
while you were working through a higher level challenge, which is like naming something. And that's,
Yeah.
and then for AWS, the scope of naming something obviously has even more challenges to it, which you were able to navigate thanks to some clever both brand thinking and also tooling. But and it's not going to be, we're not far away from a future where, like you said, it just you have this tactical thing you have to get done, and okay, let's outsource it to some agents that can do a lot of the hard work for me. And I didn't know about the RDAP versus Whois thing until you just
Yeah.
explained it. But it sounds like it was something that you discovered in the process. Maybe your agents discovered in the process and told you. Uh,
Yeah.
um,
Yeah, exactly.
and and there's one end where you'll use these products which sort of wrap the agent experience and make it easy for you for folks who are non-technical, and
Mhm.
they'll just type in some instruction. It's going to deploy a fleet of agents to get it done. And then on the other hand, you're going to have developers who either through hand coding or AI code gen can use like a nice wrapper framework to build this stuff for themselves
Yeah.
at a rate which was just not possible before. And it's from that perspective, it's super exciting, both like as a for like the non-technical consumers of AI and the builders who want AI at their fingertips.
Mhm.
I totally recommend. We'll have a link to that to your blog in the show notes as well, in addition to the GitHub repo. But I always just encourage people, like the people who are creating these frameworks, including yourself, are making it easy to run locally and then
Mhm.
deploy in the cloud. So just start with your laptop. Your laptop is most people's laptops are pretty powerful these days. There's a lot of great tooling, both especially with Python, to build really nice applications that are portable, that you can really get far on your laptop and then still be in a state where you can deploy to the cloud without changing too much in terms of just environment variables. So I do totally recommend everyone to just get hacking and hack around and play with these frameworks and try it out, because people don't even understand what they can do. uh they
Yeah.
just because it just seems impossible. Like, even if you've been in software engineering for 25 years, I hear that a lot. People just didn't understand what was possible, and it's so powerful. Like, you kind of just have to go do it and play around and get that empirical knowledge yourself. And Strands is a great framework for that. um Looking ahead, like, what foundational, so we're talking about all this, the amazing stuff that's there, but what are the foundational building blocks that are still missing from the agent ecosystem?
Well, I think one is that I'm kind of excited about is thinking about how can we reuse these agents across other developers. Like we think about we have libraries, right? And we've created this amazing ecosystem of libraries across all these package managers. But I also think that agents are kind of the new, MCP servers are the new libraries. Agents are going to be the new libraries. And so how do we share these or make them available over APIs or something where, as a developer creating an application, maybe what I'm doing is pulling together a set of MCP servers and pulling together a set of agents. I've seen that, even just with my little naming bot, I was seeing the power of being able to just pull in these MCP servers. Whereas before, I think about API integration work using some like the GitHub library, for example, would still take me a long time to write all that client code. And MCP servers, I just pulled it in and wrote a prompt. And I think that sharing agents could potentially be even more powerful. So I'm looking forward to that world where we start to share them as well, like libraries. And then I think also it's still very unsolved about building up entire applications around agents. You still have to do a lot of work to put it behind an API somewhere. You have to figure out authentication. You have to figure out, how does my like React code in the front end interact with this agent? What does it look like in the UX? I think we're still very stuck in the generative AI means chat world. So I'm looking forward to the UX around agents evolving as well, where we start to think about how could agents help in my work other than having a conversation with it. So I think there's just so much space. It's like you said, this space is changing so fast that you can't even imagine what's going to come in 3 months, right?
Yeah, and I really like your point about just being able to share agents or like sharing an API, but you have everything ready for you to use there to execute that agent. And also, one of the things that's really, it seems critical for AI applications is the traces, the evals, your kind of your integration test for the AI, like changes to the prompts. How does that actually impact the outputs? So when I come back to your idea of sharing agents, doing that in a way that also like delivers like the trust that it's
Yeah.
working the right way. And I think we're all, as an industry, trying to figure out like what are those sort of units of trust. And of course, you have LLM as a judge, and confidence
Mhm.
scores, and all these things that are really useful, and just borrowed from machine learning. I always, when I'm working with software engineers who haven't done agentic or AI development before, I'm like, that's where you should really start. Like, how, like,
Mhm.
come up with your framework for deciding like what's correct.
One of the things I've noticed working with teams at AWS who are starting to build generative AI capabilities is exactly that hurdle that us as engineers expect testing to look like: I define an input, I define an output. If I get that output, when I provide the input, then things are working. And obviously, generative AI is not like that. You can't rely on it providing you ever the same answer as what you got before. And so thinking about what success criteria looks like, what good looks like. Is it, you know, 95% accuracy of tool selection? Is it 95% LLM judge saying this is close enough to your ground truth answer? How do you even think about creating test sets and ground truth answers? These are problems that, as an industry, software engineers have never had to do. This has been ML scientist stuff, right? And so we're all kind of needing to become scientists a little bit, right? And we're not used to using the scientific method we learned in grade school at work, right? Having a hypothesis and coming up with a test and executing that test. Um, and so I think that um, evaluation tools today are still really hard for engineers to grok in a lot of ways. Even that question of, well, how do I come up with the test set that this evaluation tool is going to go through is really hard. I think there's so much room for improvement there that speaks to, the fact that we are complete amateurs in this space. I don't have a science PhD. And then I think also mapping it to the reality of the way that your users are actually interacting with your system, right? One thing that we say at AWS, for any service we launch, there are going to be customers that use it in ways you never expected. And I think that's probably true of any application. And so before you launch something, you have this guess as to how people are going to use your system, and you create a test set based on that guess. But then you have to follow back and you have to validate, okay, what kinds of questions are people actually asking of my agent, or what kind of inputs are they actually providing, and try to match that distribution in your test set. That can also be really hard, right? How do you think about that, kind of matching that data, the live data set, with what you're testing against?
Yeah, and we're sort of scraping the surface of this, but if I were to ask you generally, like, what's your advice for software engineers, whether they're new or experienced or just fundamental computer science background? What's your advice to software engineers who are breaking into AI engineering?
One is try Jupyter notebooks. That's something I had never heard of, honestly, coming out of computer science program. And then all of a sudden, I'm working with these ML and AI scientists, and they're all sending me these Jupyter notebook files. So we do actually have a lot of Jupyter notebook examples in the Strands examples repo, so that's a good place to start. But I think also thinking about, again, kind of how testing is going to look like. One thing that I often see from myself as well as other engineers is what I started to call vibe checking, which is, we know about vibe coding, but how do you know when your thing works? How do you know when your agent works? You just kind of give it a couple of inputs, and then you personally like the outputs, and then you send it on its way, right? Starting to think about, okay, how can I actually write these down and think about what do I expect the answer to be, and thinking about how you would compare, good versus not good. So I think that there is a lot of kind of intuition that you have about what is good, and what's hard is writing that down. And so trying to kind of look through what you would think of as good. We actually have another product called, I'm not going to get it right, but it's something like Bedrock Automated Reasoning. And one of the challenges that we have with that product, it basically looks for hallucinations in large language model outputs. But one of the things you have to do ahead of time is codify what is the truth. If it can only tell you it's wrong if you've already told it the truth. And then it uses mathematical proofs and automated reasoning to determine whether it is true or not when it comes out of the model. And one of the things that we found is people don't know what's true. And so what's really interesting is you start with, here's what I think is true. And then it kind of takes you through some scenarios and says, okay, if this is the case and this is the case, based on what you've told me, this would be the result. And then you say, no, that's not right. So one example is if you give it a tax code, and it does its best to take a tax code and turn it into mathematical models, then it'll give you, okay, if you are a married couple with 2 dependents, then your deduction is X. And someone who's a subject matter expert on actually doing that math can come in and say, no, and this is why. And it can go back and regenerate those models. And I think that's a very interesting for how we think about what good looks like in our application. Play kind of a game with yourself of, okay, if this was the input and that was the output, what would I like about it or not like about it? And that effectively is your LLM judge prompt, right? And so if you're able to give those kind of introspect and come up with some of those guidelines, and that can really help you to build the application you want to build, that follows what you want to put out into the world.
Yeah, I love the term vibe checking. Equally as important as the vibe coding in the AI engineering process. And we as humans, we have this natural reflex to be really good at kind of critiquing what we don't like. But it's funny how just having like a positive mindset and defining what's good in a very structured way is actually very productive for AI, right?
Yeah.
So when you're coming up with your ground truth, and you're coming up with just ways to define that clearly, and like you said, it takes intuition about the core problems that your AI application is solving, right? And I think it kind of
Mhm.
forces everyone to be, even on the engineering side, better product thinkers, because
Yeah.
ultimately, yes, having that domain expert who can define what's good and do that up front and think about the thousand scenarios of generating good outputs. That's ultimately going to be super helpful and make the AI application that much better. So
Mhm.
yes, great advice to software engineers who typically think back the other way, which is like, hey, I'm going to develop all the code first and then test when it's done.
Yes, yes. I know, it's almost like test-driven development could make a comeback. It could.
It could make a big comeback with
Yeah,
AI applications.
yeah.
Claire, it was super great having you on this episode of What's New in Data. Where can people continue to follow along with your work?
I'm on LinkedIn and I'm on Blue Sky.
Excellent. We'll have links to Claire Ligori's Blue Sky and her LinkedIn below, along with her awesome blog post going through and demonstrating Strands agents. And thank you to the listeners for tuning in today. This is a super fun episode, a lot of great insights. Claire, thank you again for joining.
Thanks for having me.